divide it to general items. One, we have the sensible heat load. So under the sensible heat load, we have the heat transmission through the structure. Then we have solar radiation loads, which is mostly coming from the sun. And we also the infiltration or leakage into the space. So ito yung condition space mo yung room. So yung infiltration ng hangin na dumadaan sa ilalim ng mga singit-singit na mga pintuan at yung bitana. And also we have yung heat emission from occupants. Ito yung heat na nire-reject ng tao. So depende doon sa type ng activity siya. It's either nakaupo. So kung nakaupo yung tao, iba ring heat ang kanyang nire-reject. Pag naglalakad siya, nakahiga, so yung heat na nire-reject niya is magkaiba rin. Parang it depends on the work activity ng tao. And we have heat from the electric lights. Yung mga ilaw natin sa bahay, what we have in the ceiling. So mostly how many watts yon, it corresponds also yung how many watts na kinukonsume niya. It corresponds also the heat released by the bulb. It added to the heat load na kailangan din nating i-compensate to maintain yung temperature ng room. Also, we have to consider also the heat to be extracted from materials or products brought inside the room. For example, dala ng pagkain, usually pagkain, bagong luto, so mainit yun. Then you have to continuously remove those heat in order para ma-maintain mo yung space at the desired temperature. And also other products that has let's say equipment or yung gamit mo which is exposed from the direct sunlight, or mapapansin nyo naman yan pag may binilad kayo, let's say yung damit nyo binilad mo sa araw for a certain period of let's say 3-4 hours. So nag-absorb na yan ng heat. So kung natuyo na siya, then ipapasok mo siya doon sa condition room, yung heat na yon, you have to remove those heat from your clothing, no, in order to maintain the temperature of the room. Then lastly, we have heat from other interior sources such as yung mga electric motors natin, and also yung chemicals. So yung motors naman, usually we have pag running siya, for example, if you want to maintain yung mga pump rooms, so the electric motor consume electricity, and by means of rotating the shaft ng electric motor, it produces friction. So those friction converted into heat, and those heat inside for example pump room, if you want to maintain temperature in the space, so yung pump room, you need to extract those heat in order for you to maintain the temperature of the room. Mechanical naman, for example, mga internal combustion engine, if you are inside in a laboratory, so if you do testing, and you need to, and we all know that internal combustion, when it is running, it's very hot. So if nakalagay yung internal combustion in a space and you want to maintain the space, you need also to continuously extract this heat as the internal combustion is running. And we have also gas. For gas naman, we have the application, we have yung mga industrial kitchen. Nakikita ninyo, mga industrial kitchen. So, for example, sa mga malls, and sa malls, usually we have mga makikita nyo dyan, example in Robinson, no? So, makikita nyo na lang sa harap nyo that is serving of food, but others are meron silang kitchen in front of you. They will show you how to cook yung product nila, or and sometimes they hide your cooking area sa likod, and those cooking areas must be maintained yung temperature. So yung heat that rejected by the combustion from the gases, you need to also extract those things from yung heat produced by the combustion. So you need to extract those heat in order to maintain a comfortable place for the sa mga nagaluto, mga chef, para they can comfortable na magluto sila. So that's it. And also we have yung steam. Usually kung magpakulo ka ng tubig, that also produces heat, no? Yung mga water heater, yung kettle, electric kettle, yung yan. So it conserves too much electric power, and also those electric power were converted into heat, and in those heat were released into the environment. And also other appliances. So we have mga appliances natin sa mga bahay. Mostly we have yung refrigerator, no? So mapapansin nyo yung refrigerator, yung sa gilid niya mainit na yun, because nowadays yung mga design ng refrigerator, yung condenser nila tinatago na nila by means of hiding on the wall. So nakatago na yan. So they using the surface wall as a means of condenser. Pero nandoon pa rin ang coil yan, nandoon pa rin sa likod yon. And mapapansin nyo, pag ginawakan nyo yung gilid ng refrigerator, mainit yun, magkabilaan. Kung wala kayong makitang coil sa likod. Yung old design kasi, usually, ang coil nasa likod, yung condenser niya. So, nandoon, yun ang mainit. If you can still remember, yun yung mga sinasampayan ng mga damit. And nowadays, the design, they made it more, tawag dito, parang magandang tignan, and it aesthetically, tawag dito, hindi siya parang maraming tinago na nila, no? So yung coil ngayon nasa wall na ng outside wall, but the surface wall is flat, but inside nandun pa rin yung coil nakadikit. So let's go to latent heat now. By definition, latent heat is defined as the heat needed by the body to change space without changing its temperature. It is defined as the heat needed by the body to change space without changing its temperature. That is latent heat, while the sensible heat is defined as the heat needed by the body to change the temperature without changing its space. So you will see that difference now. We need the latent heat sources. We have yung moisture content by means of infiltration. So we have your leakage ng air, no? And also moisture from the occupants. So yung tao, nagpapawis tayo. So you will notice that in a room. So usually pag pumasok ka in an air conditioned room, so yung palaging sabi doon tayo, yung mas gusto mo pumasok sa place na air conditioned room kasi malamig, di ba? So yun yung basic explanation natin. Doon tayo sa malamig because ayaw natin pawisan. But actually, nangyayari, even na sa malamig na room ka, pinapawisan ka pa rin. Ang nangyayari is that yung pawis mo eventually nag-evaporate mabilis because yung room where anong tawag dito, air condition, and yung pawis mo nag-evaporate, sumasama doon sa hangin. Eventually, ang nangyayari is as the I will show you sample, no? So for example, if a person, no, inside a space, in a conditioned space, and you have your FCU or fan coil unit, then you have your coil here, no? So usually yung tao reject heat, okay? So you have a rejected heat, so yung pawis mo eventually nag-evaporate, sumasama sa air, hangin. So ina-absorb ng hangin yan, nag-evaporate siya. So when the air receives moisture, it becomes saturated na siya, saturated, and let's assume it will become 70% relative humidity because it absorbs moisture, no? So pag dumaan siya ngayon sa FCU, sa foil, by means of recirculation ng hangin, those saturated air, it touches to the coil, yung coil niya, kung we have your coil here, so iyan natin, i-oversize, okay? So nag-touch yung saturated air doon sa cold coil, okay? So eventually the air condense, okay? So nagpapawis na rin itong coil na ito because yung air which is have a moisture already, when you go to the saturation curve, okay, saturation curve, that is yung psychrometric chart, no? So magpapawis itong coil because it directly contact with saturated air, and those moisture or droplets will fall doon sa pan niya. So sasaluin lahat yun ito, okay? And makikita nyo sa labas ng building so may coil ka dyan, that is a cold coil. So mayroon pang isang pipe yan na palabas, no? There is another pipe yung tinatawag natin condensate drain. Usually condensate drain, ito na yung moisture ay tubig na nanggaling sa katawan ninyo, and also nanggaling doon sa space, no? Yan na yan, the moisture were condensed na dito sa condensate drain, so palabas na siya ng building. So you will be asked, usually yung kung ikaw lang ang tao doon sa space, that is yung pawis ng tao, pawis mo na yan na dito na lumabas sa condensate drain. And if you will going try to tikman mo yung water which is pouring out in the condensate drain, mapapansin mo hindi siya maalat. So why? Because yung alat na supposed to be na dapat usually pag tinikman natin yung pawis natin, that is maalat, no? Because yung alat ng pawis natin were left behind sa skin natin, naiwan na, okay? So naiwan na siya, then what we nag-condensate na dito is purely H2O na lang. So, ang tumutulo dito is purely H2O. So, malinis na siya actually. And you can use that water to recycle kung especially malalaki yung building, no? Or a mall. Eventually, kasi ang iba, ginagamit itong portion nito as yung condensate drain, nilalagay sa storage tank. Okay? Storage tank. No? Then, those storage tank, reach mo, you can use a pump to for irrigation purposes. Sabihin irrigation purposes, pandilig, panlinis, or pwede pang flush ng toilet, what other purposes na pwedeng pagamitin, which is also a cost saving to the owner of the building, because napalamig mo ng building, then nakapag ka pa ng tubig, nakapag-inba ka pa, di ba? So one of the way to conserve energy also. So mababawasan na yung supply ng water, no? Especially kung ano ba malaki yung load ng building, tulad ng yung mostly kasi applicable na siya kung mga malalaking building, for example ang mga malls, hotels, casinos, mga cinemas, yan yung mga mostly na malaki ang load because of the multi-application ng mga buildings applications nila, and they can and you can adapt this one para maging cost saving to the owner side. Okay, so that explains yun bakit hindi tayo pinapawisan when we are inside hindi mo siya totally nakikita yung pawis mo, nag-evaporate lang siya. Parang katulad din yan ng if you're using an alcohol, no? Yung alcohol disinfectant, you will notice that pag pinatak mo yung alcohol sa skin mo, eventually just only a few seconds it evaporates because it absorbs yung water, the alcohol become it evaporates at we call this it evaporates immediately at normal temperature. So eventually it turn into to gas. So from liquid it turn out to gas. So mababa lang kasi ang kanyang boiling temperature na tinatawag natin. Okay? Yan, nag-evaporate siya kaagad. Then we have moisture from the materials or yung mga products. So moisture from the materials and products, siguro dito pumapasok yung mga pagkain. Usually makapansin nyo, especially mga sinaing, no? So pag bagong bukas mo sinaing, so mararamdaman mo yung heat, and also pag tinapan mo yung mukha mo doon, mararamdaman mo rin yung moisture, okay? Parang basa-basa, okay? So it is dagdag doon sa load natin na we need to take away the load from the building, because as much as possible we're trying to remove all the moisture inside the room, because if become saturated na yung room, you become uncomfortable siya, so parang mamasa-masa yun. So we try to, that's why we're in air conditioning, we try to lower the temperature. So we will going to control the temperature, and the same time simultaneously controlling also the relative humidity ng space para to provide a human comfort dun sa taong nag-occupy. So we'll be taking two. So yung temperature, will be controlling dalawa pala, no? We'll be controlling the temperature and the relative humidity. Next also, we can also use moisture from other interior sources. So mga wet surfaces, no? Okay? So mostly sa mga laboratory, lababo, and also sa CR. So they have wet spaces. Then we have yung sabi ko gas steam, no? Mga industrial kitchen. So nagkukulo yan yung mga heater nila, and it provides steam, and also hot water, and electrical and other appliances, mga water heater nga, as I mentioned earlier, no? For the space heat load items, one, we have sensible heat gains in the space. So we have the heat transmitted through the structure. Okay? So from yung heat transfer natin, no? Going back to the subject of heat transfer, it was already discussed, this one, so we'll be reviewing na lang. So if you can still remember, no, so heat, different material have its own thermal conductivity, or they have on thermal resistance. Okay, so that corresponds to the how much they can emit and stand the heat transfer from one portion to another. Heat transmission to the structure, because sa building we have your walls, mostly kasi that we have here in the Philippines, ang nangyayari is ang wall natin were made of ano lang naman, so were made of hollow blocks and sets of mortar. So yung mapapansin nyo sa bahay niyo, we have yung CHP, o yung tinatawag na concrete hollow blocks. Then we have yung plaster. So magkabila yan usually. So plaster cement, o yung most layman's term, we have yung tinatawag natin na ano yun, they call it this is also plaster. They call it layman's term, tinatawag natin palitada, di ba? So, para it smoothen yung surface ng walls. Okay. Then lastly, we have your paint. Paint is so manipis, will not be considering na rin yung paint because it's already so we'll focus mostly on the concrete structure. Ayan, mga makakapal na lang. So usually yung plaster, 3mm or 4mm thickness, depends on the later on we'll talk about that one. Next we have the solar radiation. That is the radiation coming from the sun, no? So hindi lang init that we are emitting, no? We have the if you can still remember, in heat transfer we have convection heat transfer, conduction heat transfer, then we have your solar heat transfer. We'll be considering also later on, we'll talk about that one, yung solar radiation. We have yung solar loads through transparent surfaces. Dito pumapasok yung mga glasses, no? Yung bahay ng mayroong mga windows were made of glass. Okay, it contributes to the heat load, yung solar radiation. So magkaiba kasi yun if solid structure, no, tulad ng mga CHP. So magkaiba yung kanilang solar radiation compare doon sa mga glass or mga transparent surfaces, especially if you have yung mga high-rise building were made of glasses, no? Yung mga walls ay outside walls ng building are made of all glasses, single pane, double pane types of glasses. So may encounter natin yan along the way. Then also we have the solar load on opaque surfaces, so yung mga non-transparent surfaces that we have. Okay. Then we have the infiltration of air leakage into the space. Okay, so ganito, usually if we have your door, no, pintuan ng bahay natin, then we have yung they call in English yung door jam, or sa Tagalog, layman's term, tinatawag na nating hamba. So, if you're going to zoom in doon sa portion na yan, there is a gap between. Yan. Hindi naman siya totally fit na fit ng size. There will always be a gap. Mapapansin ninyo yan. Kahit saan kayong building pumunta, there will always be a gap. So, yun yung pinapasukan ng hangin, which is kung titignan natin sa side view ng building nyo, if this is your door, so this is yung flooring natin, and this is your door. So yung pumapasok ng hangin dito, no? At sa mga gilid na yan, especially if this is a conditioned room, if you're going to maintain the other room ng 24 degrees Celsius, and the outside dito sa labas niya, other room niya, or let's say that is an hallway, and that is already in 35 degrees Celsius. So if you can still remember in physics that heat transfer from saan tumatakbo ang heat, that is from hotter body to a cooler body. So ang flow ng heat is going doon, okay? Papasok. So the flow of heat will be from hotter body to cooler body. So kaya papasok talaga yung init dito doon sa loob ng space, and that is one additional cooling load na dapat nating i-consider. And also yung mga bintana natin, especially kahit yung sliding door, no, meron pa rin yung leakage portion. So we need to take account on that one for the cooling space. Then we need also to consider the heat emission from occupants. Yung tayo, sa tao, no? You will notice if a person is running, for example, sa gym, and also it rejects more heat, no, compared to people sitting in a room, no. Mapapansin nyo rin naman yan, no? Compared to people sitting in the room. You will also notice that why mapapansin nyo rin yan yung class, no, na yung even na hindi kayo sa condition space, no, yung heat na let's say pag tumatakbo kayo, no, you will observe that yung body temperature ninyo increases. Yung temperature ninyo increases compared to let's continue. So sabi ko nga, mas mataas yung temperature, yung compare ng temperature na is mas mataas compare doon sa temperature pag naka-occupy yung tao. Okay, so that's why later on makikita rin yan sa aklat. You can see that within the stopper we have different types of heat emitted ng bawat person in different types of activity. There is a corresponding there is a corresponding latent heat, no, latent heat and sensible heat for every activities ng tao. So it's either sitting, running, even sleeping, class. We reject heat. Sleeping, ano pa ba activity we do? Walking, okay. Yan. So we produce heat for every different types of activity that we do. We produce heat. Then the heat emission from electric light Okay. So, yung mga bumbilya natin sa bahay, you will notice, mayroon tayong makikita nyo, there is 20 watts, 40 watts, 60 watts. Okay. So, this is the power they consume in order to produce yung liwanag dun sa space. And mostly, 90% yung how much their wattage, kung ilan yung wattage ng mga bumbilya natin sa bahay. So, 90% of it is rejected. The heat rejected is rejected to the room or to the space. Okay? So, kung may bumbilya tayo dito, kung 20 watts yan, it emit or reject almost 90% ng amount ng value niya, kung ilan yung wattage niya. Kaya that's why kung mas maraming bumbilya o mga bulb yung room, so the greater the electrical load, heat load from the lights yung naipoproduce nun. And it is also one we need to consider para ma-maintain natin yung space at the desired temperature. Next, we have the heat to be extracted from materials or product brought in temperature higher than the room temperature. So, ano ba ito? One sample is the heat emitted from yan, katulad yan, if you are staying in a hotel, so bili ka ng Pizza Hut, okay? So usually mainit pa. So mainit pa, maybe that is around 45 degrees Celsius. Okay. So you need to remove the heat ng 45 degrees Celsius yun. Para ma-maintain mo yung mabawasan or ma-maintain, you try to maintain, maibaba doon sa condition space. Let's say 22, 23, right? And also, for example, yung kakain ka, order ka sa, then also you have yung rice, right? So, mainit yun, it produces heat, it contributes to the load ng room, okay? Then, we have heat from other interior sources, such as motors, chemicals, okay? Motors, example this one, yung electric motor natin, no? So it produce also heat din. Ito yan, mga electric motor, yung mga malalaki, meron din, there are places where yung are exposed into harsh environment, no? So yung room need to be conditioned para mag-function yung mga electric motors ng matagal. Pero kasi kung especially from hotter places, example Dubai, Middle East, so yung working environment nila, they're already starting at 30 and pinakamainit is 44 degrees, no? And relative humidity is napakataas, and yung tinatawag na harsh environment. So kung naandar pa yung electric motor, which is via starting temperature niya, ganun na kaagad. So, maiinit na siya, no? Mas iinit na masyado siya if tumatakbo na siya. And also, ang magiging problema nun, one of the causes is yung bearings niya mas madaling ma-worn out. And also ang shaftings, because you have an initial temperature, so yung thermal expansion, so one of that one is also thermal expansion, and also yung deflection will also be affected if yung motor are not designed on that type of environment. But mostly ngayon, manufacturers are designing their electric motors which is applicable to those type of harsh environment. But pero there are times na mga manufacturers, mga producers, yung motors nila requires a delicate condition. Okay? And we have yung chemical reaction. So mga chemicals, mostly in mga laboratories, pharmaceuticals, school laboratories, experiments, the reaction of chemicals also produces heat. And we have your mechanical for internal combustion engine, no? We have that one. So now notice mo, this is napakataas ang heat ang nire-reject nito. And we have also another mechanical. We have your reduction gearbox. So yan also emit heat din yan. Nire-reject din yan ng heat. So for continuous use, so there will be a friction moving, and those friction na pinoproduce between bearings and parts and lubricant are converted into a heat init. Okay? Then we have also yung mga gas. Okay, we have yung steam, no? So yung pakulo ka, yan. So usually in yung kitchen yan nangyayari, mga industrial kitchen. Yan yung mga load na dapat reconsider, no? And also in sa mga shower, we have yung water heater. So ito yun, it produces heat. Parang maligo ka, you want to ma-experience mo yung tama lang, maligam-gam lang na tubig, and you'll be using a water heater para parang maligo. And also that one contributes to the heat load. And also we have yung electric water electric kettle. So this one is emits malaking load because it requires higher electricity consumption. Mapapansin nyo, just only this is only a minutes, minsan seconds lang. Mga 1 minute I think, ganun. So yung 7 liters mo will reach to 100 degrees Celsius agad. Okay. Then we have also yung mga laptops, okay, that also produces heat. So makikita nyo rin yung wattage niyan. Makikita nyo, so if you have your laptops at home, so laptops na ginagamit, so itaob ninyo flip side, and tignan nyo sa likod kung ilan yung wattage consumption nyo or input wattage nyo. So we try to assume those wattage consumption are also the heat rejected by the unit. And also the same also, we have your desktops, the same also. And also yung refrigerator, as I'm saying, is yung heat na nandito mostly kasi nga design na siya na in a mas magandang aesthetically design. Yung coil niya dito na nakatago sa gilid na yan. Okay, as I was saying before, yan. So these materials and equipments contributes to the heat that you need to consider para ma-maintaining yung space at the desired at a design condition. So let's proceed to the latent heat gains in space, no? So the infiltration by air leakage, and you have your vapor pressure difference. Ito, sample niyan, you will notice this man is using yung windows niya. This man is putting using a sealant. Tawag natin, using a sealant para yung mga gap and spaces doon sa pag-install, kasi hindi naman siya 100%, mapapansin niyo sa mga bahay, that is not a 100% seal tight. So that's why yung iba, they're using a sealant para also para yung mga gap and spaces where control mapilapan. And that is one of the also contributed to the infiltration by air leakage. So ito yung one of the example sa windows, and we have also yung mga sa doors. And also yung tinatawag na vapor pressure, no? Usually if this is the space, Okay? And you have your environment sa labas. Usually, ang pressure mo dito where different at the vapor pressure mo dito at vapor pressure mo dito is magkaiba. So usually from your PBMRT yan, from your gas. So if this is a lower temperature, if you're going to compute the volume in the pressure in this room using the PBMRT, and you have your mass in the air and the temperature inside, so magkaiba sila kaagad. So if you're going to compute the pressure that is by means of PBMRT, so by same volume, same mass, same R, okay, so magkaiba ang temperature. So this is maybe 23 degrees Celsius and your outside mo is 35 degrees Celsius. So you will see the difference na. Magkaiba sila ng pressure. Eventually papasok talaga yung hangin dito sa space. The air outside the space will try to push in doon sa low pressure. So especially kung ang room are not completely 100% sealed tight. Usually that is sa mga bahay-bahay, hindi na rin masyado kasi napapansin yan. So that and that contributes to the heat load. Then we have the moisture of occupant. So pag pinapawisan tayo, yan, we need to remove those moisture doon sa tao. So by means of air conditioning, those moisture are being removed by means of evaporation. So and also if you can still remember physics or biology yata, so yung perspiration, yung pagpapawis natin, is a method ng human. So it is a methods of human in order for cooling. So mapapansin nyo, pag nainitan ka, eventually nagpapawis ka. So it's a one way of characteristic na meron tayo, no? Na pag pinawisan tayo, eventually our body will pag nainitan tayo, eventually our body will try to cool the body by means of yan, pagpapawis. So yun ang one of the characteristic that we have. So it's a great thing that na meron tayong characteristics na gano'n, no? So kung God created us in such a way, kaya nga pwede mong we can say that God is a greatest engineer of all times. So pag imagine na one way na design ng humans are in such a way para pag nainitan nagpapawis tayo, and in one way of cooling the body. So yung naman, yung mapapansin nyo rin yung one way of cooling yung mga same also what we have yung sa mga animals, no? So hindi lang naman tayo. So animals also have their own way of cooling, katulad ng elephant. Okay, yung elephant, so mapapansin nyo, meron silang mahabang tawag dito, yung tenga nila, ears, malapad yan. So mapapansin nyo, it flap, parang nagpapaypay yan siya. So that is one way of cooling ng mga elephant. So makikita nyo, pag nainitan yan, parang nagpa-flap yan siya. So hindi sila pinapawisan, but in a way, yung flapping ng kanilang tenga is a method of cooling their body pag nainitan. So ang galing. So very kung iisipin mo, God created all these things and it is very beautiful and napakagaling kung if you're going to if you're going to consider na who invent us, is napakagaling, which is God. Yeah? Then yung also the same also yung mga baboy, no? So yung mga baboy, yung mga pig naman, you will notice also yung tenga din nila, no? Malaki yan. So it flaps din yan every time na naiinitan sila. Hindi kasi sila pinapawisan. So, it's a one way of cooling, yung flapping ng tenga. Kaya mapapansin mo, yung animals that do not have yung pinapawisan, so, mapapansin mo, yung tenga nila is a one way of cooling yung tenga nila. And then yung mostly yung nagkakaroon ng heat transfer. And also yung mapapansin mo, yung also yung mga, you will notice also yung mga animals in cold places. So you will notice also katulad ng mga polar bear. So makakapal yung mga balahibo niyan. So that is one way, no class? That is one way of heating nila. Okay? So hindi mo yan sila po pwedeng, kung polar yan sila, so you cannot bring them in the Philippines. Or you can bring bitawan mo sa Philippines na ganyan. So eventually mamamatay sila because yung environment nila which is negative environment. So kung ilalagay mo sila dito sa Philippines, bibitawan mo in a while, so eventually mamamatay sila because yung heat magiging napakainit na doon sa katawan nila because yung balahibo nila and also yung part ng skin nila are makapal in order to protect themselves from the harsh environment ng polar. Kaya, pero pwede mo rin naman siyang dalhin in the Philippines, but you have to put him in a conditioned space. So yung mga ilagay mo siya sa air conditioning space or refrigerate. So usually kailangan mo siya ilagay sa refrigeration because you will try to build up a negative temperature. Okay? So yan yung mga natural ways ng tao in a way of for cooling and also to protect them in a harsh environment. So eventually we cannot survive in those type of environment. We can survive but we'll be using other means. So mag-jacket tayo na napakapal and also yung mga jacket on those meron na yan and also we have yung tawag natin dito, yung nowadays yung mga jacket are equipped ng equipped with heater. So there is a heater coil or heating filament nakasurround dun sa jacket niya, and is battery operated in order to keep the temperature inside your coat na maintain yung temperature for human comfort. So that exists already. So isa na one way na you can go to negative temperature places para you can walk through and survive in those. But again, you'll be needing to supply heat in order to do that. So you need energy para to maintain yung body temperature mo. Then we have yung moisture from materials or product in space, then moisture from internal sources such as wet surfaces and chemical gases, steam, hot water, electrical and other appliances. You will notice it is the same, yung katulad din diniscuss ko kanina before going back this one. So usually they have their moisture content in their reject. So as the heat rejected, there is also a moisture being transferred. There is a moisture inside yung mga product natin, pagkain, food. For example, the chemical reactions, and also ito mga water heater, you have the kettle. So they have the corresponding moisture na nire-release that we need to take away from the space in order to maintain a comfort, in order to maintain comfort and human comfort para sa mga tao or the occupant of the building. And we have yung outside ventilation air. So those outside air ventilation, so we have ng sensible heat gain from temperature difference, no? So, paano nangyayari yon? For example, we do ventilation because it's very important, no? We supply the space, if this is the space, no? Okay? Usually, you have the volume of air here. So, yung volume ng air mo is made of different types of air. So we have CO2, different types of CO2, argon, helium, and so on, diba? So usually humans consume we have also yung oxygen. So usually if you have the volume, usually ang kinoconsume lang naman ng tao is oxygen. We have your O2, kinoconsume niya, and nire-reject niya, which is yung nire-reject natin, which is becoming CO2. So kung wala tayong ventilation in the space, wala tayong ventilation sa space, eventually yung space mo ano mo siya, tawag dito, ma-reach up o ma-maximize mo yung oxygen doon sa space, yung mauubos mo, ma-maximize mo yung oxygen sa space, and eventually the room will be filled with CO2. So the content will be CO2 content will be greater than the O2 content. So that is yung nagkakaroon sa ng, kaya minsan dito nahirapan kang huminga in one space because yung oxygen content niya is mababa. And one way of doing is to supply a duct sa space by a mechanical means. So we have your fan. So that is yung tawag na mechanical ventilation, para magkaroon tayo ng fresh air doon sa loob ng building. So we're going to supply that one dun sa space. Eventually we need to extract also yung CO2 mo doon. So you have also another duct para i-extract naman yung mga tawag dito, unwanted na air content nung doon sa loob. Eventually yung para mawala yung tawag dito, yung old lumang hangin. So we try to extract by means of mechanical ventilation also. So this is ang tinatawag natin na ventilation of air. So usually this is outside maybe around 35 degrees Celsius, and you're trying to maintain the room maybe 23 degrees Celsius. So you will see the difference, no? So the types of difference of temperature between the outside and the room. So you need to also compute and add it to the load ng building natin. And also may corresponding latent heat yun, no? Palagi magkasama yan, latent heat and sensible heat. So yung moisture, how much is the moisture nung outside and the moisture nung sa loob, will be how much yung moisture doon sa loob. Okay? So there is a difference in moisture nung sa labas and also in dun sa loob. So that will be also added to the air cooling load ng space. Especially ngayon nowadays, so especially there is a tawag natin na call this yung sakit na COVID-19, no? We have your COVID-19, and we try to, as much as possible, all rooms, no, must have call it ventilation para yung hangin doon sa loob is mapalitan. And usually pag in-confine in a space, mas madali ang transmission ng sakit. Kaya that's why we need the ventilation para yung lumang hangin doon is being removed. para hindi na siya maka-affect ng ano. Eventually kasi mas madalas yung especially pala ng mga manugal application is yung sa mga hospital, no? Especially iba-iba yung mga sakit ng tao doon. So you have your flu, and kumbaga nandoon na lahat yung sakit na pwede mong makita, and yung very hazard talaga siya yung environment niya. I know, very hazard siya. So nandoon na lahat ng sakit, mga TB, so tuberculosis, so flu. So eventually that is can be like by means of cough. So the droplets nung can be transferred sa hangin, then from one patient to another pwede i-transfer yung sakit kung kulob yung space, so kung walang mechanical ventilation. So kung may mechanical ventilation ka ng fresh air tsaka yung exhaust, you have your exhaust dyan, exhaust fan, so you can control the environment properly. Also, one of the yung mostly kasi nakikita natin sa bahay, which is yung natural ventilation, makikita lang natin na sa bahay, natural ventilation is by means yung sa mga bintana, doors, and windows, we have yung filtration. So ganun yun, by temperature difference ng outside ng 35 degrees Celsius, so maybe siguro mga 28 degrees Celsius. So natural ventilation, so the air flow by means of temperature difference, so nagpo-flow yung, or by means of natural ventilation is by densities of, also by means of densities of air. Okay, so magaan doon ang hangin, eventually by natural wind it will be pushed in sa loob ng mga bahay natin by means of some doors, windows. Okay, so yun yung we need to consider for the load ng building natin.